Okay, so we are in chapter 3 now. In chapter 3, we're gonna talk about exponentials and log functions and applications. So we did talk about in chapter 1 and chapter 2 about two kind of function, which is linear functions and quadratic function. I would like to introduce another kind of function, which is called like exponential function. Okay, so what is an exponential function? Unless we have an exercise with us. Okay, so hopefully I would like have this with a partner. But as you watching these videos, I would like you to pause my videos and try the best to to fill out all the space that we have for the table down here. All right, you can pause my videos, and when you're done, go ahead and turn on it. Okay. All right. So as you see in here, consider two companies. Company A has 100 store. Okay, let's highlight that. Come and expand by opening 50 new store a year. All right. So is adding 50 every year's plus 50 store, right? For company B is have something different, still with 100 store, but it expand by increasing the number of store by 50% of their total each years. So so this is adding constantly, right? Adding a constant, and it is adding by a rate, like a percent, like 50%, something like that, right? Okay, so let's take a look at now table below here. We try to fill out it. Okay, so number 3, number 1. Row number 1 is talking about give you a year, company A, company B, right? So row number column 1 is for year, column 2 is for company A, and column 3 is for company B. In the initial year is 0 here. Both of them have 100 store. Okay. After that, after 1 years, company A just keep adding 50 more. So that means they're gonna have 150 store. In company B, they will add 50% up 100, which means they will add hundreds plus with 50% of hundreds, which means 50. So hundreds plus with 50 going to be 150. Okay. So look like in the first years, look like the amount like they have total store total store are the same, right, for both company. And what about in the second years? Second years, company A just keep adding 50, right? So this always, as you remember, like in linear, we can just keep adding 50 to the next year, right? Keep adding 50, right? Adding 50. We keep doing that. So this is a linear function. Okay, so the number of company of store in company A in GNM 3 gonna be using 200, adding with 50, it's gonna be 250. and then using 250, adding with 50, go be 300, and then keep going with 300, adding with 50, gonna be 350, right? And then 350 will be 400, right? So this is clearly is a linear, right? I'm gonna say this is a linear. Okay, linear. Okay, so now let's take a look at B. This one changing by a rate. Okay, so it's not like constantly 50 store, right? So it's just keep adding 50% of the previous store. So right now, we're gonna have like the next one is 250, and then adding with 50% of 250. Oh, sorry, 225, right? 225. Adding with 50% of 225, which is just 225 divided by 2. So what is that going to be? So use the calculators, you will have 225 plus with 112.5, and that will be equal to, we will say 337 0.5, but because since it is like a number of stores, so we're gonna just say um like make it a route number and say it as just 337 only. All right, because this we I decided to route down since I don't, because I don't have enough money to make it about 338. So I have just enough money for open 112 more store. So that's gonna be 337 store. Okay. The next K gonna be uh-oh. 337. I'm gonna use it. 337, and adding with adding with 337 divided by 2, which is gonna be 337 adding with 168.5, right? So that's that will give me 505 store. Okay, and we do the same. 757. Oh, sorry, 505 plus with 505 divided by 2, which equal to 505, adding with okay, let me see. I just figured that I made a mistake here. Let's see. We actually come from 4 and jump to 6 year. It's not um it's not 5. So let's we change a little bit, so he is according to that. So I have to have like 300 adding with hundreds, gonna be 400, and this one's then it is 400 2 years after that, so gonna be 2 years 2 years, so gonna be hundreds, it's gonna be 500 here. All right, so that mean I also have to change this. Okay. So it was 505. This one is different with the one in company A. I have to have the fifth year first, right? The fifth years will be 757. So like if you do as what I actually decide to change my mind and not doing 2 years in here. I would like to just do 5 and 6 on it. So 5 here, 6 here. So I will have this one will be 300 plus 50 will be 350. And this one will be 350 plus 50 will be 400. So then 505 you add with 505 divided by 2, 50% that. So that's gonna be 757. No, let's just write as 505 plus with 200 and see 505 divided by 2 will be 20252.5. So that's gonna be 757.5. And again, because I just have enough money to roll out and make it 5757 star. And this will be 5757 plus with 757 divided by 2 we give us as 757 divided by 2 going to be 378. 757 plus with 378.5. That will give us 1135.5. And I will make it become 1135 star. Yep. So for this one, we're gonna have the graph. We're gonna have the graph, the points for each company. Let's say company A is in red. Okay. We have 0. It's hundreds, right? So put our hundreds here. Maybe so here. And then let's do 1 and 150, right? So about a little bit higher. And then 2 is 200. 200 here. Good. And then 250 in the middle. Oh, right here. Yeah, frozen. And then we have four, right? 300. And this is about somewhere here. And then I have 445, 350 somewhere up here. And then 6 is gonna be 400. We can have 7 as 7 nearby at 450. So 8 gonna be 500. So yeah, we can just connect all this. Yeah. That is for company A. It's gonna say company A grow by X amount. Yes, linear. Or we can say linear function. Right. I will do company B as blue one. The first 2 points going to be the same. From the second point will be, the third point going to be different slightly. And third one, and then fourth going to be 337. Somewhere here. 505 is the next. 757.5. Somewhere here. 1135.5. The next one. And you can try with 8 to get 2053, 2053 up here. Yeah. Okay, so we draw the curve. All right. And we call company B. Grows by a percent each year. This growth we call is quicker than linear. We call exponential growth, exponential function. Say that. That's all. Let's we try another one. So we want to try to write a formula for company A. Okay. And company A has 100 store and expand by opening 50 new store a year. Company B has 100 store and expand by increasing number of store by 50% of their total each year. So let's we try to write the formula for company A first, right? Maybe I'm gonna split this to be a half like this. Okay, and say for company A, let me use smaller. This is a linear function. Since it change, it increase constantly 50 store per year. That means we will have slope equal slope m equal to 50. You can also using the slope formulas to find this one, but as by definition for business slope, you can just that each year is increased by 50. That means slope will be 50. All right. So another way you can do is using formula say m equal to, you can choose 2 points, something like that. So say initial one, say 0, 100, right? It's years. And so maybe, okay, so this is interpolation. So let me use as year and then number of store, right? So we have 0, 0 gonna be 100 store. We have 1 years have 150. So you can have 150 minus 400 divided by 1 minus 0. You will get 50 divided by 1. That's give you 50 at a slope. Okay, so then we have y equal to, no, actually, oh yeah, that's okay. Just write as y equal to mx plus b, right? Right now we're gonna have y equal to 50x plus b. What's a b? Substitute a point. Let's choose point 0, hundreds there. Into the equation, we're gonna have hundreds equal to 50 times 0 plus b. So then you're gonna have hundreds equal to b. All right, so that means the function will be for company A is y equal to 50x plus with hundreds. Okay. And I can say where x is number of year and y is number of store. Maybe just gonna say this is years, right? Yeah, so that is for company A. Since company B is changing by the rate, so I would like to have, that one. So for company B, is increased not constantly. No, I would say like it's increased by a rate. And we call that as exponential function. So how can we have that? How can we have the formula for it? Let's have some pattern. Right. So let's say for 0 years, we have x equals zeros. We have y equal to hundreds. Okay. We have x equal to 1. Then we have y equal to hundreds, and plus with 0.5, that's 50%, right? Time with hundreds. Okay, let me factor it. I have hundreds time with 1 plus 0.5. Right, and I will get something. Let me make this 2 here. And we get 150. So multiply. Let me this line here. And I will make better. Okay, better. Okay, so that is for x equal to 1. What about x equal to 2? Right? We have y going to equal to hundreds and plus with 0.5. Now I time with 150. So that's going to be hundreds time with 1 plus with 1 plus with 1 plus with 75. No, sorry. This should be 150 here. I missed some mistakes, sorry. And then factor 150 out. And we have 1 plus with 0.5. I'm thinking this. And I'm trying to get connection between x1 and x2. So let me see. I will make this 150 here become hundreds plus with 1.05. So let's change that. This 150 here Now I change it to be 100 times with 1 plus 0.5 and time with 1 plus 0.5, right? So I see that I can write it as hundreds times with 1 plus 0.5 to power 2, okay? Or, or, simplify, I have hundreds plus time with 1.5 square, right? So the rate is 0.5 still there, but 1.5, I mean 1 plus 0.5 become 1.5 square. Okay. What about x equal to 3? I will have y equal to 2 to 5 plus with 0.5. This equal to 2.5, 2 to 5, okay? Time with 2 to 5. And again, I can change it to be, let me write this. Change it to be 2 to 5 times with 100 times with 1 plus with 0.5. And I move this down and write as y equal to 2 to 5. I want to write as hundreds times with 1 plus 0.5 raised to power 2 and multiply with 1 plus 0.5. And now I simplify one more time, have y equal to hundreds times with 1 plus 0.5 raised to power 3, right? Because I combine those two. And now I will have y equal to hundreds times with 1.5 over 3. I see that there's some pattern. There's some pattern now. I saw the power here is going to be the same with the number of g, right? Similar like number of g's in x equal 2 here will be the power 2 for the form of x equal to 2 there, right? So I guess, okay. So I guess the numbers of store for company A, company B will be using formula y equal to hundreds times with 1.5, 1.0, 1.5 is okay. Raised to power x years, okay? Or another form going to be hundreds time with 1 plus 0.5 raised to power x year. So as you can see, let's go up with it. The hundreds here will be the starting value, right? And the R or the rate here. This is the rate. The 0.5 was the rate at 50%. All right, so that is the formulas for each companies in here. I would like to show you the graph for A and B there, right? And I also want to show you, from now on, you will learn exponential functions. We call it exponential growth or decay function. So there's two K for that. It could be grow F or decay as decreasing. So so that means we split it to be two things: exponential growth or decay function. It is a function that grows or swings. So grow or swings at a constant percent growth rate. The equation can be written in the form as LT will be equal to, I'm going to use A times 1 plus R raised to the power T, or LT will be A times B raised to T, where B equal to 1 plus R. Okay, so I will use, and I want B greater than 0 and not equal to 1. So I would like to have so in here we have T is the number of time interval elapsed. A is initial or the starting values. So let's say A is initials, T is time, R is percent growth or decay rate, written at decimal. B will be growth or decay factor. And keep in mind that B is equal to 1 plus R. If you have R, you can find B, or in another conversely, you can find R will be equal to B minus 1, right? So keep in mind that you don't want B, you must want B greater than 0 and B not equal to 1, okay? Just because, think about if B less than 0, okay, you will have if B is equal 0 first. If B equals 0, it will make a constant, because B raised to anything, 0 raised to anything will be equal to 1. Will be equal to 0. So that's going to make a constant 0 for the function, and that become linear. If B is less than 0, it's not become a function anymore. So we will not talk about that case. And if B equal to 1, that's also will make a linear, since you have B 1 raised to anything is equal to 1. So all right, so now let's move off. Okay, so we're gonna working on exercise 3.2 here. As a group, think about given the statements below, identify which represent exponential growth or linear growth. So actually, think about the cost of living allowance. We using the word the shortcut way is COLA. Yeah, COLA. Right? For state employees, increase salaries by 3.1% each year. So if you see in here, right, 3.1% each year, right, we mean you would think that this increasing by rate, okay, increase by a rate. Right? Let me make it smaller. Okay. What about the next one? State employees can expect a $300 raise each year they work for the state. So this one maybe we'll say raise by a constant as $300, right? What was the last one? Tuition costs have increased by 2.8% each year for the last 3 years. So it is increased by a rate. Okay. So try to think about which one in here gonna be the answer. Okay. Try in about 1 minute and we're gonna check my answer. Okay, go ahead and try. All right. So you can see that we have the first one is by rate. That is exponential growth, right? Why, right? The second one is by constant. That is linear growth. And the last one is also by a rate as 2.8%. That's exponential growth. Okay. So now let's we go ahead and working on example 3.2. Okay, so we look at the two functions below that represent the balance in two different saving accounts. Determine the initial value, the growth rate, and the growth factor. We have AT equal to 1000 times 1.05 T, and we have BT will equal to 900 times with 1.075 T. So according to the formulas, right, of the exponents, this exponential function. So the one, the A over here, small a over here, the one like before the parenthesis will be the initial amount, right? So come back with the function here. I may remember that right now they are using the form without 1 plus. So they are using the form ft equals to a and b raised to t. Okay, so I'm gonna write is above it to make it easy to see, right? A times B raised to T. Ft equal to A times B raised to T. Okay, so now I think you can see it better. So the initial will be the A, which is 1,000 there, right? For the first one. And the second one will be 900. Right? That's going to be the A. What about growth rate? Okay. The rate, I mean, you need to, you know that the rate going to be R, which can be defined as using B minus 1. And right now we have B as 1.05 minus 1 will be 0.05. So that's the growth rate. I use other color. And I will also do the same thing for this guy. I got B, this A is 1.075. 1.075 and minus 1, I will get 0.075. That's the answer with that. Okay, so lastly, growth factor, which is B, we given already, so you can just put out that value as 1.05, and this B equals to 1.075. All right. So you can see that there's something that you need to consider. They are different, but have a relationship with is growth rate and the growth factor. Right. The growth rate is noted by the R that we get always, like, you know, less than 1. I could say that, and growth factors is always is greater than 1, since you adding 1 with the growth rate. So we're gonna have notation for that is B. Okay. So which account is growing faster? Okay, that's based on the I mean, we having okay, so for this one, actually, let me see. Actually, because it's talk about growing, how fast it's grow, right? So we should need to check with the rate or the growth factor, like compare between those. So you can have which one is growth factors. So in here we have company B have growth rate as 0.075, which is greater than company A, which has 0.05. Or as you can compare, the growth factor is B in company B is 1.075 is greater than growth factor in company A, right? So I can just go ahead and say company, or maybe just say BT, because growth factor or growth rate is higher than 80. All right. And I will say, okay, so I would like to let you try on this one. You can try to fill out this and check with my work after finish it. Okay, so you can see that I after 3 years by using the function for company A and company B as previous problem over there, we can have 1157.63 for the company A, and company B will be 1118.07. So week one is gonna have week one will have higher balance. As you see, I have the first one as 80. Keep in mind that this question is different with the question say which one is growing faster, much faster, right? If I'm talking about growing faster, I'm talking about growth factor and growth rate. But if I talk about which will have higher balance, then you will have to check with the balance. Okay. So after 3 years, I will see that the company A will give you the higher balance, something like that. In 6 years, you will do the same, but you change the 3 to be change the input here. Change the input here to be 6, right? All right. So then you're gonna have 1,340.10 for the company A, and B gonna be 1,388.97. So that's gonna be B. And last one for 10 year LEC, you will also do input change to be 10, and company A will be 1,628.98 and B will be 1,854.93. So this is more much higher than A after 10 years. Okay, so according to this, the balance, or I'm gonna say the values in the future, I'm gonna note that. All right, note. Future values can be future value depend on initial values and growth rate or growth factor, right? So it's not only by just initially or only by growth rate. So as you see here in 2, I know that the way is growing is company B is going faster in the long run. Yes, absolutely. The amount of money they have in here for the balance will be higher, much higher if you try to have more year, like 20 years, something like that. But like in the first 3 years, you can see that company A still have higher balance, right? So is the reason was in company A, I did use the initial amount was $1,000, and company B was just $900, right? So now we move to the next example, 3.3. Let's say populations. Okay. So populations of thousands is decreasing by 3% each year. Oh, okay. So how come population can be decreasing by 3%? Usually it could be like some kind of population, like some some species in the red book already, right? It's kind of like people or human try to make effect with it, or even like environment make some effect, and they decrease the population. So that's right. But normally populations increasing. That's usually okay. But let's see. Anyway, just follow by the formula by the given here is decreasing by 3% each year. Find the population in 30 years. So I'm gonna follow by the function as p of t will be equal to a times b to raise to t, or I should say I should use a times 1 plus r raised to t in this case. Remember that we are given the rate as 3%. Okay, so I go highlight as r equal to 3%. And I write it in decimal, 0.03. Okay, so that's mean I am given this guy right now. Okay, let's we write down. A going to be equal to 1,000 in its initial amount, and the rate. I forgot one more thing. It's a decrease. So I would like to subtract. I would like to have negative here. So that means it's negative 0.03. So then I have right in here is negative 0.03. And that means the base will be 1 plus with negative 0.03. So then I will have 0.97. Okay. Let me check with my base again. 1 second. Okay, good. All right. So yeah. So we have therefore, let's say therefore the function of the population is in the formula, in the form P of T equal to 1,000 times with 0.97 raised to power T. So I will have P of 30 is 1,000 times with 0.97 raised to power 30. So I will have, what is that going to be? Let's try this. You may have to use a calculator for this one, okay? I have 401.007. Okay, so the 401.007. Right. So keep in mind that since we are using populations, right? We may have to route it in the whole number. It's going to be 401 only. So I'm going to say after 30 years, the population will be 401. Okay. So I would like to let you try exercise 3.4 and 3.5 and fill it is and submit it as a group work. I would like to give you the answer key. Let's say after let's say 50 years. What is that gonna be? I write 1, 2, 6, 9. Okay, 1269. Because and it's routed to the nearest integer only. Okay, so try that and also try the one next to it. I would like to have this as so initial value or is given growth rate. You must make sure have it. And the number of smartphone contract grow by, okay, let's see. Something in percent. And I'm gonna write this one for you, but you must show me how to get that number 64. Right. And there was approximately 200. No, actually, just leave it for you. Okay. Yeah. So I would like to leave this for you to practice with. All right. See you in the next section.